Hello, welcome back. It was my intention to create an inventory UI. I've been posting some stuff like that on Twitter, but in going through the walkthrough, it turns out we really need to just kind of address like a very simple pet buy system to get an inventory to work with the UI. So that's going to be this video. And when I say simple, we're going to make some very simple pets again. We'll stick with cubes like we did last time, and we'll just create a very simple buy system. Now this is again modeled off the agent buy system, and so shouts out to the creators and maintainers of that. But I'm starting to kind of deviate from that a little bit. There are minor rooms for improvement as we go along. So let's get to it. So I have a blank canvas here. We are blank base plate. So we have created this from new. There's nothing in it. And again, we're going to create this from scratch. So the first thing we're going to do is make insert a simple part, and we want that part to be a cube-ish. So let's scale it out to be a cube. It doesn't have to be perfect because we're not modeling pets here, right? So on that cube, we want to make that cube part of a model. So I'm just going to go ahead and search model in workspace and insert it, and take that part and stick it inside a model. And then I'm going to rename the part to humanoid root part. And the reason we're going to do this is because later on when we're doing some movement, the humanoid and root part and inserting a humanoid, let's go ahead and do that, into the part allows things for like hip height for off the floor, which makes it very much easier to manage when they're following. So we have a humanoid root part, which is just our cube, and we have a humanoid in here. This gives us some things to animate and manage while we're moving later. And it's, I guess roughly cubish. I guess we can simply make it a cube. Let's go in here, let's look at size. Let's just go 4,4,4. Now it's a real cube. So we want to find the face of this. And when you're modeling your pets, if you've watched some pet modeling videos, I am not a modeler, so it's probably not likely to get one of those from me, but you do want a front face on this thing, because part of the scripting is we need to be able to identify the face and make sure things are working correctly. So I'm going to go ahead and insert on humanoid root part a texture. And that texture can be anything, simply to just identify which is front. So on that texture, I'm just going to use the question mark for the empty slot that we used last time. It can be anything. Just upload a picture as a decal, and then grab that number and insert it to texture here. And this gives you a face. So now you can see we have a cube with a face. And to distinguish pets this time, I'm going to also on here going to add a particle emitter. Now, I guess the traditional way that you do pets is like gold and rainbow and whatever. But for this one, you just want to do something a little different. So we're going to do a particle emitter. I'm going to set the lifetime to 1.2, so we get very short particles, and you can put your own graphics in that and change it and play with it however you want. But this is what we're going to use to distinguish different types of pet from the same origin. So now we basically have that pet, and so let's go in here and we're going to duplicate it. And so we have that one, and that one, and that one, and that one. Lost track of how many duplicates I did. Alright, so now we have 6 different pets. So we're going to let's turn these 3, which is that one, that one, that one. Conveniently all next to each other, looks like. So here, here, and here. Yep. Those 3 we are going to set to, let's do green. So we're going to select that one, and that one, and we're going to set that to green. Let's do really green actually. So 255 and 0. Oh, that's right. There we go, green. And so with the other ones, let's open up those. So it's this one, and that one. So we select all of those, and we're going to set this to yellow. So 255050 yellow, yay. Okay. And so now we have green pets and yellow pets. So we'll call these green cubes and yellow cubes like last time. And we're going to just change the particle emitter colors to reflect the different types of pets this time, rather than having, I think last time we did big, sit and regular. So on this one, let's go ahead and set the color to yellow. Oops. Let's not do that. Texture, color 3. Let's do yellow. Oh, sorry guys. Particle emitter. What is going on here? Particle emitter. The color we want it to be yellow. All the way yellow. And then on this particle emitter here, we want this one to be green. 255,0. So these will be our normal pets. And then let's do like a fire and ice theme this time. So on this one, your particle emitter, let's make this one fire. So 255 255,0. And then on this particle emitter, we do the same thing. 255,0. And then on this particle emitter, let's see, let's make it ice theme. So go in here. This time we'll just make it something like that. So that's 33, 240, 254. I'm just going to copy that and go over to this particle emitter. There we go. So now we have like a fire and ice theme, and these will be our special type of pets. So now what we're going to do is we're going to create inside of inside of Workspace, we're going to create a folder. Actually 2 folders, so let's duplicate that. And this folder we're going to name green cube, just like last time. And this one we'll name yellow cube, like last time. And then we're going to take all of the green pets, and we're going to put that in green cube. And we're going to take all of the yellow pets, and we're going to put that in yellow cube. This one. Alright, and so this one is going to be normal. We're going to rename that to normal. This one is going to be fire. This one is going to be ice. That's another normal one. And I'm not entirely happy with the way that this is set up. But for right now, we're just going to stick with it. I think this is one of the improvements I'd like to make to the pet system. But, alright, so now we have normal fire, ice, normal fire, ice. So these will be our types. So let's get on to some other prep work. So we need to stick these pets down in replicated storage so they're not just laying around in the map. Though I guess you could leave them laying around. So let's go ahead in replicated storage and create a folder for all of our pet information. So this is pets. Oops. So when you create a folder, we need to name that pets. Pets with capital P. And then let's take our green cube and yellow cube, and we're going to stick those down in replicated storage pets. So inside of pets, we're going to need some other information. So let's go ahead and create another folder inside of pets, and we're going to call this models. And we're going to put these actually models, because we're going to put other stuff in pets. And again, this is off the agent system. So inside of replicated storage, we are going to need to create some other information. So when we create a pet, if you're thinking about it, right, is we have models, but we also have information about the pet. So because we have information about the pet, and we don't necessarily want to tie that to the models, we would rather be able to have it in like a convenient place. And so inside of the pets folder, let's create a template for the pets as we create them. So if you think about it, right, we've created the models, but there's nothing like strength. If you're going to use these pets for something other than just show, there's no information about them. And so we need to create a template to work with to create data about these. So let's go ahead and create another folder, and that folder we're going to name pet folder template. So inside of the pet folder template, let's think about what we're going to need. Well, normally you're going to need like a pet ID, which is going to be a number value. Pet ID. We will also need, I mentioned strength, so that's also a number value. And we're going to need type information. So we created 3 different types: fire, ice, and normal. So we're going to need that, and that's going to be a string value because it's not a number. So string value, and we're just going to call this type. For right now, I think that'd be okay. Now, though, we'll need to add to this as we go along, but this is something to work with. So now let's go ahead and create a very, very simple UI to basically buy the pets. So in Starter GUI, we're going to create a screen GUI, and let's just call this main. Now normally main would be like the buttons that are always up. So inside of main we're going to create a frame. In that frame we are going to set relative. And the reason we want the relative at both position and size is that you will grow and shrink with your screen. So the anchor point is going to be 0.5, comma 0.5. That's the middle of your screen, or the middle of the anchor point is the middle of the GUI, and the position is going to be also 0.5. So 0.5, comma 0, 0.5, comma 0. Oop, missed a comma. And that puts it in the middle of your screen, and the size is going to be a full screen. So that is relative, so it's 1, 0, 1, 0. And let's go ahead and set the background transparency to 1. So all of this is if we have this frame here, we can, if we'll go back and set this to 0, we can make it visible and not visible. And everything in it becomes visible and not visible, so that's what we want. So we're going to set that to visible for right now. We're going to make it fully transparent so we can't see anything. And inside of frame, since we're creating a super simple thing, we're going to do a text button. And the text button we'll put here. The size for this, I'm going to make it static. So let's do 0, 100, 0, 100. And that makes it 100 pixels wide. And it will stay that, but you notice that the position is relative in here. So if we change the screen size here, right, the button moves around with our inside that frame. So now we have this button. This is in the GUI pretty exercise, right? This is in making pet system. So I'm not going to spend too much time on this. So let's just scale the text and let's just call it buy. Yay, that's our buy button, and that's about as far as we're going with that. So what we want to happen is when we want to click on this buy button, we're going to buy a pet. So inside of, let's go ahead and name this buy button. Inside of this buy button, we're going to create a local script, and that local script is going to be the buy script. And inside of this buy script is when we click on this button, we want the buy something in the buy script to happen. So this is going to be a connect. So let's go ahead and look at what we need for this. Well, so inside of here, let's go ahead and identify what our buy button is. So buy button is equal to script.parent. So that's the buy button that the script lives in. And then we're going to need replicated storage eventually. So let's go ahead and do that. So local replicated storage equals game.replicated storage. And we'll need some other things, but for right now, let's just leave it like that. And so now we're going to do the connection. So buy button, which has a member here that is buy button one click. So, and then we're going to connect. So this happens, what we're doing here is when you click that button, we're going to connect a function. And right now that function is basically going to, well, it's been clicked, so that's where we are. And to make sure, let's go ahead and print now. So hopefully, if we go in here now, we haven't done anything with our pets yet, but if we click our buy button, you can see that the buy button's been clicked. So that doesn't do a lot. What we want to do is buy an egg. The problem is we're in a local script. We're running on the client side. We want the server to handle all eggs. Man, you don't want the client to handle eggs, because then people could just add eggs at will with an injector. So we want to ask the server to do something. And if you want to ask the server to do something, you got to go through a remote event. So inside of replicated storage, let's create a folder. And that folder we're going to call remote events. And inside of remote events, since what we want to do is buy an egg, let's just create a remote function, not an event, a function, and that function is going to be, let's do egg open. So now when we click this, what we want to do is we want to go to egg opened and ask the server to do something. So we're going to need some other things in here. First of all, we're going to need local remote events equals replicated storage, wait for child, remote events. And then local egg opened, which is what we just named that, is equal to remote events, wait for child, egg opened. So now we have access to this remote function, and that remote function will run on the, tell the server to run another function. So what we're going to do here is egg opened, and we're going to invoke server. And right now, we want to send it an egg name. Well, we haven't done that yet. So to kind of connect with what we've done previously, I'm going to go ahead and do a little extra work. You don't have to do this. You could just send an egg, and you could statically put information in there. But I recommend that you kind of stick to what we're doing in previous videos, so that you can kind of connect it all together. So the egg is, we're just going to call this first egg. So when we call egg opened, it's going to invoke server with first egg. Right now nothing happens because nothing is connected to this remote function call. So to create something and connect it to the remote function call, we are going to need to create a server script. And that server script needs to go in server script service. And this is going to be our egg handler. So what we want to happen is when the button is clicked and egg opened is called here, the server script service egg handler will connect to that remote function call. And that is pretty simple. So get rid of the hello world here. The very last thing in here is where we want egg opened .on server invoke, and we're going to do something, and that's going to be a hatch egg. Now we don't have egg opened or hatch egg yet, so egg opened is just like before. If you go into the buy script and copy this stuff out, not the buy button, but just that's what we want, right? So now egg opened on server invoke, we're going to hatch egg. Hatch egg is a function. So that function, let's put it right here. So local hatch egg, and you're going to send that player and the egg. Now player is sent by default. And this is a function. Player sent by default. And in ByScript we just sent first egg. So that's what's going to come out here. So let's go ahead and do a print statement here to make sure things are running correctly. And we're inside function hatch egg. Let's go ahead and do the player.name. Egg. So if we click this, if we play now and we click the button, we're inside a function hatch egg. So we made it to the function, and that's happening on the server side now. So inside of here, what do we want to do? Well, first let's do some sanity checks, and so we're going to check if the egg exists. Well, it doesn't exist because we haven't done anything. But first thing we want to do is check egg exists. So where are we going to get the egg from? So if you remember in the previous video, we made all the eggs in a module script that was in replicated storage. So we're going to create a module script in replicated storage, and we're going to name this eggs. So inside of eggs, we're going to do something super simple here. This time we're only going to put one egg in here. So we're going to have local egg is a list, and that list is, the first one is first egg. That comes from ByScript right here. And that is also going to be equal to another list. And we're going to return an egg down here, by the way. So inside of here, we need a cost equals 100. Pets equals yet another list. And the first element in this list is going to be yet another list. And that is going to be name equals green cube. Type equals normal. Green cube is going to be in paren or in quotes, string level. So type equals normal. Chance equals 80, and strength equals 10. And let's go ahead and copy that, put a comma, put another element in the list. This is going to be the second one, and this is going to be yellow. And let's make that chance of 20 and strength of 12. Alright, so that's all we're going to do on this. Obviously you can create more eggs if you want, and look at the previous egg UI video to see some examples of that. But this will create our egg. So let's go back to egg handler, and we're going to check to see if that egg exists. And how we do that is, let's look at it. Well, we want if eggs. Now we don't have eggs yet, so let's go ahead and put that in there, and that's going to be an import from the module script we just wrote. So let's do local
eggs equals require, because it's a module script, and that's replicated storage, wait for child, eggs. So now we have an eggs variable, which is our module script. So remember, the module script is returning a list. So what we're getting out of eggs is a list. So let's go in and check to see if that egg exists in the list. So we're simply going to look for egg. So remember, first egg is coming in here. So if the list eggs contains an element first egg, which it does, if we haven't misspelled anything, then that works. So if this is not nil, then and we're going to do something, right? We're going to print, right now, let's print hatching egg. So if we play this, we should get a hatching first egg, and we're getting that misspelled hatching, but that's right. So we're hatching first egg. So we're in there correctly. I'm going to kill that print statement. So now what do we want? Well, we want to grab all the information out that we just put in there. So local data is equal to egg, eggs, egg. And so now we've grabbed that list. And so data is the list from eggs here. So it is this list here. And so now let's get stuff out of that list. So local cost is equal to data. And we're looking for the cost element inside there. And local pets, which is a list, is equal to data out of the pets element. And the pets needs to be in quotes. And so now we got the information out of there. So we also need to do some debouncing here. What we don't want is somebody to come in and be able to hatch many eggs. So we're going to put a debounce inside of here. So local debounce is equal to false. And let's do a for I be in pairs. And we want this pairs to be a list of people hatching eggs. So I'm going to call that player debounce. Well, player debounce doesn't exist yet, so let's go ahead and create that. That is just an empty list to start. So local player debounce is equal to an empty list. So now we can iterate over that list, and we are going to look for player's name. So if first element in B equates to player.name, probably should be ID. I'll go and fix that later. Debounce equal to B.to. And this later on we're going to add names to this debounce list to make sure that players are not hatching bunches and bunches of eggs asynchronously. So now we want to call basically hatch a single egg. And the reason we're going to do that is because later on, if you add other stuff in here, you might hatch triple eggs, you might do auto, you might do whatever. So we're going to do local pet chosen is equal to single egg player egg. Now single egg doesn't exist, so let's go up and create it. Again, a lot of this comes right directly out of the agent system. So hopefully this is giving you understanding if you're using that system. So let's go ahead and create this function. So function single egg, and we sent that player egg. What are we going to do in here? Well, we want to hatch an egg. So we're going to need to get a lot of the stuff that we did before. So we're going to need this stuff here. We don't need a sanity check. Maybe not hurt to give one, but we usually don't need a sanity check because we did it here. So we're going to get pets all the way down to there, and now we're going to do a local current pet is equal to choose pet, and we're going to send that to the egg. Now choose pet doesn't exist. Let's go ahead and create that function. Function choose pet egg. And let's go ahead and let's do some sanity checks to make sure that we're making it all the way there. So I'm going to do a print statement here. So print function choose pet egg. Let's go ahead and do let's do here. And then this one we're going to be this one is single egg. Play that. Let's go in and make sure that we haven't misspelled anything. And it looks like we made it all the way down. So we're in a function choose pet. So inside of choose pet, again, we're going to need we won't need cost, but we will need pets. So let's go ahead and put that in there. And now we're going to do some calculations. So the way that the agent system has it set up is that while you kind of make it like 100 to get it right in your head, doesn't have to be perfectly 100. So we're going to do local total weight is equal to 0. And what we're doing here is we're going to iterate through here and look at the chances. We're going to add them all together and then use that as the end of our random choice to make sure that we're picking the right pet. So first thing we need to do is iterate through all of the chances and add it to total weight. So that's for I be in pairs pets, which is a list above, do total weight is equal to total weight plus v dot chance. And v is every pet inside of pets. So now we have we've iterated through that. We have the total weight of everything in there. So now we need local chance is equal to math dot random, and that is a number between 1 and total weight. And then we need a local counter is equal to 0. My students will love the fact that I put a counter in there. So for I be in pairs, we're going to iterate through pets again. Counter is going to be equal to counter plus v dot chance. Now if counter is greater than or equal to chance, then return v dot name. And this will return the name of the pet. So let's see if that's actually working. So let's print here, and we're going to print per egg is current pet. There we go. Let's play that. Hey look, we got a yellow cube right off the bat. So now, what do? Well, we have a current pet, but we've just selected it. We need to actually duplicate all the information. We need to clone it, put it in some kind of storage container, all of that, right? So start with local settings. Yeah. Is equal to well, let's grab the model first. So local current pet model is equal to replicated storage dot pets. I don't like that, so let's go up here and create that. So local replicated storage underscore pets is equal to replicated storage wait for child pets. So now here, let's just do rs underscore pets dot models find first child current pet. And so that will grab the model and put it in the current pet model. So now settings is equal to current pet model find first child pet settings. Well, this doesn't exist yet. So there are some things that you might want to put in your pet models. And Agent certainly does this. I think some of it might need to be taken out, but for right now, let's go ahead and use part of this. So pet settings is a folder inside of models. Or inside of pets. So let's see, replicated storage pets doesn't exist yet, so we want to create a folder and call that folder pet settings. Well, what do we need inside of pet settings? We are going to need but you know what? Right now, I think we can deal without that for this video. So let's just skip that for now. So the next thing we need to do is make sure that single egg is not being hatched many times in asynchronously. So this is our debounce for I be in pairs. Player debounce do if first element in V is equal to player dot name. This should probably be ID, guys, but I'll have to fix it later. Then V2 is equal to false. No, equal to true. All right, so that says player name equal to true. And now we want to spawn a server-side wait. So spawn function, and we're going to wait for, let's say, 4 seconds. Not 40, 4 seconds. This means that a player will only be able to hatch an egg every 4 seconds. If you don't do this, they're going to be able to hatch eggs as much as you want. Now, you might want to use this as a variable and pull that variable out of settings, because you could create game passes to hatch eggs faster. That's common. So, but right now, let's just leave it static. And so for I be in pairs, player debounce do, and if first element equals player name, then v2 equals false. What this will do is every time this is set to true, it will spawn this function and it will wait for 4 seconds and then set it to false, so that the server-side wait happens. Now, we need to clone all of our information into our pets. So again, we need to find the current model and the current information. So we're going to iterate through to find it. So for IV in pairs, pets do, and this iterates through pets again, and it finds if v.name equates to current pet, then we found the right pet, and so we're going to start cloning stuff. So local clone equals replicated storage pets pet folder template clone. This will clone that folder, and inside of that, so clone dot pet ID, we want that to be value. We want a random pet ID. Random ID layer. So this will probably, I'm going to use something super simple here, but you could use GUID functions or something here. But let's just do something super simple for right now. So function random ID player, and then putting player in there because you might want to do some kind of GUID later. So local rand equals math dot random. Let's just do 2 and 1,000, 1 million, 1 billion. I think random can take something that big. For I B in pairs player dot pets get children do and what we're doing here is making sure that there's no other pet inside of your inventory that's the same ID. Now this is not going to work with a trading system because you'd have to respawn IDs, so you need to call like a GUID service for that, but this will work for now. So if v.petId.value equates to rand, then call itself, return random ID player. And if it doesn't, then we're going to return rand. So this will make an ID that's unique, and we can set that inside of here. Now moving on from there, let's go ahead and put all the rest of the information that we might need in there. So clone dot strength value, and that's going to come out of eggs. So that's b dot strength. Clone dot type dot value also comes out of eggs, so that's b dot type. Clone dot parent is equal to player dot pets. This is going to give us a problem. We haven't created that yet. And then let's put this here. Clone dot name is equal to current pet. So well, what are we going to do here? So the problem here is we don't have pets. So unfortunately, we're going to have to go in and create some of this, which is really a data store issue. But let's go ahead and do that right quick, so that we're not going to actually save anything, but I'll give you a template that will work with future videos for data store. So for data store is going to exist inside a server script service, and it's going to be a script, and we're going to name that data store. Inside a data store, we're going to have 2 folders And one folder is going to be named pets. One folder is going to be named data. And inside of data, we're going to need this later. So let's go ahead and input 2 number values. One number value is going to be named max storage. And one number value is going to be named max equipped. Now, data store is responsible for storing and repopulating data when you create the game, but normally you also use it to set up a new player. So to set it, all we're going to do in data store this time is set up a new player. We're not going to save anything. So what we're going to have to do is get the player. So local players is equal to game dot get, game called get service, and that is players. A local data store is equal to game dot call get service, data store service get data store, and let's call this player data alpha 1.1. So as you progress to release, you'll change this, but this allows for testing and messing up things without having to go in and edit the data store all the time. And we'll also need local replicated storage again. So local replicated storage is equal to game.replicated storage. All right. So in order to use this, you're going to get an error right now because this is an API call. So you're going to need to save your game to Roblox. And so let's just call this pet by video. So pet by video, we're going to save that. We're not going to use Teams. Is saved now, and once you save it, you can go to game settings and go, I believe, to security and enable API access. So hopefully we don't get any errors now, well, except for that pets that we haven't created yet. So right, pets is not a valid member. So let's go ahead and fix that, and that's going to happen here in data store. So we're not going to store anything this time, but what we're going to do is set up a new player. So players.player added. Connect. Function player. So players gets passed in on player added by default. So now we need local pets is equal to instance .new folder, and then we're going to need data to do the same thing. Then let's do pets.name equal to pets, data.name is equal to data. I want that capitalized. And local saved data is equal to data store get async data store get async player user ID. All right. So this will, the first time it will be nil, and if we save data, next time it wouldn't be, but we're not going to save any data here. So we're going to do if save data is not equal to nil, then it's a returning player. Else, it's a new player. And so we're going to do a player setup. So for IB in pairs, script dot data dot get children do. So this is this folder here, and we're going to iterate through that and do local data value is equal to v dot or v call clone, and then data value dot parent is equal to data. If data value dot name is equal to max storage, equates to max storage, or, and this is a string literal, so it needs to be in quotes, it's equal to max storage or max equipped. Then now we need to set some default values here. So data value dot value is equal to replicated storage pets dot pet settings find first child default string literal concatenated with no spaces default value dot name, and then dot value. And what this will do is it will go into pet settings here, and we'll look for something named default data value or default max storage or default pet equipped. So let's go ahead and put those in there. Those are number values. And this is going to be named default because it's looking for the name max storage and default max equip. So we're going to set that to 105. So now if we play it, see if we get any errors. User ID is not a valid member of player ID on data store 14. That is because user ID is strictly to camel, so it is that. Okay, expected call and get children, so data store 20. Oop, right there. Alright, pets is not a valid member or player on ByScript 11, so pets is not being duplicated in there yet. Let's take a look. So player, Kara play, or some players, Kara plays. Didn't happen. This should have some pets in there. So let's take a look at what's going on. I think we forgot to set it. Yep, we forgot to set it. So after we've made all this information, we forgot to actually set them. So pets.parent is equal to player, and data.parent is equal to player. Now let's run that. Pets and data are there. and it all seems to be working.
So, if we go back to workspace, and I guess we need to be playing again, and let's see if the entire pet system is working. It should be. So we go in here, we look at players, and that pet and data that we just created is there because that is in our script. And notice that pet's empty. We hit buy 3 times, and we end up with 3 green cube pets. So that's the very simple pet system, and at least to do a buy system. And next we can work on inventory. Talk to you then. Bye.